Today we talk with Kacper. He's a developer advocate in Qdrant, the best vector database on Earth, on the planet actually, I think. So Kacper, introduce yourself, tell us something about you.
Hello, Piero. Hello, everyone. Thanks for the invitation. Yeah, so I'm a developer advocate at Qdrant. Have experience with software development, machine learning, the traditional one, and right now I'm doing a lot in terms of embeddings, because everyone wants to do embeddings, especially combined with large language models. So that's a hottest topic on the whole planet nowadays.
So let's start to talk about this. A lot of people is following us. They are starting to hear about the language models and embedding. So we already know what language models are. Let's keep that for granted. When do embeddings come into play?
Yeah, so that's quite a common question nowadays because people started using large language models as if they were knowledge bases. They expect them to know some facts,
Yeah.
and they just want them to produce some texts, some content, and treat them as some sort of oracles. But it's not the case. It's not true. If you really want to use the properties of those systems to generate text that sounds like if it was created by a human, then you really need to incorporate some additional knowledge, like the documents that you possess, maybe the data which is private for your company and that the model was not exposed during the training, because it obviously won't know the facts that it was not trained on. And those models also tend to hallucinate. So they might be producing a text that sounds okay in general, but simply turns out to be false. So text embeddings and embeddings in general, not only text embeddings, but text embeddings are usually used to build a semantic search knowledge base. So this kind of knowledge base might be searched over using natural language, and that's the huge advantage of using embeddings over the traditional keyword-based search. For example, if you are using anything based on Apache Lucene, that was usually performing some normalization of a text just in order to find the keywords. Right now, you can use natural text queries, and that will work exactly the same, like with the keyword-based search before. So, in a nutshell, you build your knowledge base using vector databases or vector search engines. This is how we prefer to call Qdrant. And it might be used in order to find some relevant facts given your prompt. And this additional context might be then used to create some sort of meta prompt to the large language model. So instead of asking a question related to some common knowledge, you are just converting the task to extract the information which is really relevant from the content that I provided you.
Great. We're talking about another, how do you call the sequence of letters representing a concept? Acronym.
Yeah.
Sorry, my English sometimes goes away, I'm getting old. So the system you're talking about looks a lot like RAG, Retrieval Augmented Generation. Why is called like that? Why is a search engine like Qdrant is used for Retrieval Augmented Generation?
Yeah, maybe I should start with describing the term in the first place. So basically, retrieval augmented generation is a quite a fancy name to describe. Well, the concept itself is not that complicated. Like, if you just have a look at what is really executed under the hood, it seems to be quite simple. But when you start implementing it, there are so many challenges in that. Then you definitely need to have some tools that will be solving them, just not to reinvent the wheel. But basically, retrieval augmented generation is an some sort of extension of using generative models, generative AI. But instead of expecting the model to produce the text on its own, we are just providing some additional context, so to say. And this is what this retrieval does. So basically, this is a process that retrieves some relevant information, and it is relevant to your original prompt. So let's say if you wanted to find the capital of Italy, the model should already know that, but maybe there are some smaller countries that won't be so easy to be find out, and then it's way better to just extract some facts from even from Wikipedia if you work with common knowledge, but maybe some third-party data providers as well. And those additional facts are just put next to your original prompt, and the whole challenge of this large language models is to extract the meaningful piece of information instead of trying to make it up.
Great. So another question that follows up after talking about the retrieval augmented generation is why should that be better than fine tuning? Why using a database for vectors and make a search in vectors and fill up your prompt with content retrieved from the vector DB? Why should that be better, and when it is better in respect to fine-tuning the model, changing the weights?
Yeah, so basically fine-tuning is an option, definitely, but it's an expensive one. And well, you would possibly fine-tune your model if you work in a very specific domain. Let's say the base model that you use was trained using some common knowledge, some general knowledge. And if you work in, let's say, in chemistry, and you have a specific terminology that the model was never exposed to, so there are no tokens representing whole words that you have in that specific terminology. So that's a proper use case for fine-tuning, but this is expensive. And this is great if you really want to extend the dictionary of the tokens supported by the model. So this is a proper idea to fine-tune, but other than that, fine-tuning takes weeks or days in the best case. So you will never be really up to date with all the facts, and you never can control that model was properly trained on all the facts that you have. There might be some missing pieces here. So if you have a poor large language model, then fine-tuning might be an option, an expensive one. You need to collect the training data set, structure it properly. So you need to have probably a team of data scientists working solely on that part. But if you want to do, if you actually want to use those language capabilities of the model, you can just provide those facts, and this is way easier to maintain in the long run. You can easily manipulate the facts that you store in the knowledge base. You can remove the old ones, put some additional ones, and they will be available for your model just within a few milliseconds. You upsert the documents, and then the model may use them whenever they are required. So that's definitely way cheaper.
I totally agree. I can attest that Qdrant is really fast, like a few milliseconds in a lot of points. We are using Qdrant extensively in the Cheshire Cat. We are now also in your documentation. We are really proud to be part of the family of Qdrant users. We are really affectionate to the system. And,
Yeah, that was a great addition to our docs. Definitely missing piece.
Thanks. What I think is, retrieval augmented generation, I agree, it's better because it's cheaper. You can always keep the long-term memory of your assistant up to date. Of course, you can do many more things, also search engine, but no, we use it from the assistant point of view. And also, what I find really important is, retrieval augmented generation is perfect for content. Fine-tuning, I would go to fine-tuning it for task-related changes, like when you need the model to do something else. But when it comes to language and chatbots and talking about contents, there is no better way than a vector engine.
You're absolutely right. Like the good example here is when you have a large language model that was trained on natural language and you want to do code completion tasks, for example. The model itself doesn't know the language syntax if it was not exposed to this kind of data. So that's a perfect example. But actually, there is so many more additional ones. But yeah, this is a great explanation, I would say. If you have a different task that was not solved during the training phase, fine-tuning is your option to go. But majority of people usually use those general purpose models. So
Yeah.
I'm just trying to figure out a good example of when people were doing fine-tuning properly. If you create an application, then you usually just need to choose the proper model, and that's it. I'm not sure if like a single developer can can't probably do the fine tuning on their own. It's just quite expensive.
Yeah. Retrieval augmented generation is for the stay. I think it's winning big time, big time. Another question I would like to pose you is, uh, my followers know Python. They spend some time on scikit-learn, TensorFlow, PyTorch. And now they are moving to transformers, to LangChain, to this kind of libraries, and to the Cheshire Cat. How do you get started with Qdrant on the technological side? Because really, we're going to use it.
Yeah, so definitely if you want to use your vector database Qdrant, so to say, just directly, it should be pretty easy if you use any of the supported languages. We have some official SDKs. For example, Cheshire Cat uses our Qdrant Python SDK.
Yeah.
So this is the easiest way to start with if you just want to experiment and maybe tweak the process of search. But I would say for anyone without prior experience with using this kind of tools, or maybe without experience with using large language models, it's just way easier to start with a tool similar to the one that you implemented, because it already has, well, the retrieval part is not a big deal. I would say I would say it's solved. There might be some specific cases in which you might be struggling with that, and that may require some fine tuning of the parameters of that. I don't mean the parameters of the networks, but rather like parameters of search, because this also has some tweaks which are possible to be done on the search level. But there are so many additional challenges, like you have your long documents that has to be split into chunks. And if you don't know that, if you just put all the documents into your embeddings model, that won't work. So there are so many challenges that people are just not aware of before they start. So that's way easier to start with using a tool that is quite popular and will be supported in the long run, that solves some of those existing issues. And I would say definitely, if I had to choose, I would be definitely choosing a tool that might be easily extended. So definitely go for open source, because your data might be just different. You might be using non-English data, and it has some specific challenges which are language related. So definitely open source tools and anything that can do this repeatable stuff on your behalf is your way to go.
We're seeing in the cat community that you're also moving to an embedding proposal, tools to fast embed text
Yeah.
and images. Can you talk a little to us about that initiative?
Yeah, so FastEmbed is another library that we created in Qdrant, and that was an initiative made by Qdrant, one of our developer advocates from the DevRel team. So this is a feedback that we get quite often. People were, well, I need to start with the whole story of Qdrant maybe. So we started as a vector database that is embedding agnostic. So we do not care that much on how you create your embeddings. If you want to work with a specific kind of data, then you probably know the best way of how to create embeddings out of them.
Agree.
Qdrant follows the Unix philosophy of doing one thing right. And we want to make vector search efficient, but in the long run, we have so many users and they are using some open source models. They fine tune those open source models for embeddings. Some of them use some non-standard data types and they just build their own neural networks capable of creating the embeddings out of those data sets. And we can never foresee what is the network that we are going to use. But there are also so many standard models that are like the first choice whenever you start implementing semantic search over text, for example. And many people just use those existing pre-trained models without any further fine-tuning. So that's why we created FastEmbed, which is a convenient library on its own. You can use it without using Qdrant at all. It's also based on ONNEX runtime, so it's really fast even on CPU. But you can also use it along with Qdrant client Python SDK, and then you can simply choose a model that will be used for all the app search and search operations. And under the hood, the client will create those embeddings without you even seeing that it's actually happening. So this is like a convenient method if you work with some pre-trained models. And definitely in the future, we are going to support more and more models. This is also an open source project. So if you see a model that you would like to have implemented in FastEmbed, feel free to go into our GitHub and contribute to the project. That might be even more easier than with our core, because core is implemented in Rust, great language, but entry barrier is high. With FastEmbed, we use Python, so it's way easier to start if you have any prior exposure to Python code. You worked with, I don't know, scikit-learn, as mentioned, PyTorch, whatever. You should be also able to contribute to FastEmbed. We follow some well-known principles here.
Great. Speaking of that, there are two guys in the Cheshire Cat community, Nicola Procopio and Marco Valenti. Hello, guys. They are pushing a pull request to FastEmbed to support a model that we think it's international level but lighter than the multilingual one you already support. So we are there is a special interest there.
Yeah, definitely. So that's a great place to contribute the model to as well. Definitely, if it's open source, why
Yeah.
can't we just make it public to the community? Probably there are so many users that might just benefit, and that's also a mission of Qdrant. So we share the same view here. Like, how can we make the retrieval augmented generation or interactions with large language models just more pleasant to people, and how to make sure that everyone can do it. And the names that you mentioned, I actually know both of them. So this is a really great community, a vibrant one, and definitely encourage you to follow both guys because they share quite an interesting stuff from time to time. So really great to be up to date.
Thank you. I wanted to tell you also about the choice of building Qdrant only for points. You already embed your stuff, and then later on, orthogonally, have a module to embed. You know, one of the first criteria for which I chose Qdrant for the Cheshire Cat is because there is a lot of offering around now about vector engines, vector DBs or vector search engines. But what I like the most about Qdrant is, okay, there is an in-memory based, file-based, container-based Dockerized, and it only embeds. The API is simple, and now you have a piece you can add, but it is not intermixed. So I really like this approach. That's why I chose Qdrant for the Cheshire Cat, and now that you created FastEmbed, we also have an adapter for FastEmbed.
Yeah, and I believe that's the way how we should implement this kind of applications. Like, if you work on a simple demo, then you may prefer having everything in one place, like running within a single container. But usually the embedding models have completely different scaling patterns. So they're usually launched on GPUs,
Yeah,
and vector DB definitely doesn't require having a GPU. So those should be split to different machines.
totally.
So one set of machines should be doing the embeddings only. And for years we've been implementing the systems using microservices. So the different machines have different responsibilities, and that's exactly the same thing here. Like, we shouldn't be running, for example, a web application and use the same server for calculating the embeddings, because when we experience high load, we scale both components differently. And machines with GPUs are also quite expensive.
Yeah.
So if you need all the machines to have a decent GPU, that will cost you a fortune, even though you could probably scale a bit your web application server. And this is basically cheap, but might be also launched in serverless mode. So if you have high peaks of load, if you experience this kind of usage patterns, then why should you care about improving all the components in exactly the same way? That's not the way how things should be implemented, except for some simple tasks, like if you have a few users or if you can really afford calculating the embeddings on CPU because you use a specific model that works well on CPU, that's fine. But you should have the choice, and that shouldn't be tightly coupled, I mean, the embeddings and the vector search phase, because they are completely different.
Another question for you is about the future. What are you planning for the next weeks, month, years? What are your ambitions, your dreams?
Yeah, happy that you asked about that, because definitely we are planning the next release, Qudrant 1.7, and there will be one feature that actually lots of features, some minor improvements as well, but at least four big features, and one of them being the support of sparse vectors, because up till now Qudrant was only supporting dense vectors created by some neural networks. We see that people want to have sparse vector support so they can implement something like BM25, for example. The method that people were just used to be implementing for search in the past. So we definitely need to provide them this functionality. If that's a blocker for anyone to start using Qudrant, that will be finally supported, and this was long-awaited feature supported by expected to be supported in Qudrant by so many people that we finally decided to make it happen. Also, something that I'm pretty excited about as well is the Discovery, aka Exploration API. We see that there is so many cases in which the search is not enough, so we are just exposing an additional API for that. Previously, we had our recommendation API. Right now, that will be some sort of extension to it, so you will be able to provide pairs of positive and negative examples, and that will just divide the search space and take just one smaller subspace of it. So you will be able to just interact with your vectors in a completely new way, and that probably enables so many new use cases that we haven't seen so far. As far as I know, we are the only vector search engine really investing a lot of time for all the scenarios beyond a simple vector search, and that's another thing. But there is more to it, and I really encourage you to have a look on our website. The release will be announced hopefully this week, and there will be definitely a release article describing all the features. So if you are struggling with a problem that couldn't be solved with the existing means, there might be something that you will appreciate having. And still, like, our general mission of Qdrant is to make vector search affordable. So definitely we are not stopping here. We released a binary quantization, which is a great technique if you work with OpenAI embeddings to reduce the memory usage even by up to 32 times. So that's not the end. We are definitely going to incorporate more and more techniques just to make sure that everyone can implement semantic search, no matter how big is the how big are the requirements for the memory. We are just going to reduce them.
So thank you. I encourage you guys to try Qdrant. I will leave a link in the description. Also, if you try the Cheshire Cat, you will find the Qdrant is fully integrated in tests, in development time, in production time. And we are really happy to collab. Thank you, Kacper. We can go freestyle and say hello. I'm really glad you've been here with us, and I hope you do well. It's a great project.
Thanks a lot. Well, I personally never worked on the core of the library, but I will just say to our engineering team that they did a good job. I love that feedback. Thanks a lot for the invitation, and I'm looking forward, hopefully, for some more collaboration with you and all the projects that you might be building on Cheshire Cat.